we're going to add these two rational functions. Now, in order to be able to do that, we need a common denominator. For example, and I'm just going to, you can pause it, copy out this question. I'm going to show you a quick numerical example to prime you as to what we're going to do. So let's say we had 1 over 6 plus 3 over 12. Right away at a glance, you can see that 12, if you factor it, is actually 2 times 6. 12 is equal to 2 times 6. And it becomes obvious that on this side, if you multiply this top and bottom by 2, you have a common denominator. So we have 2 over 12 plus 3 over 12. We're going to employ exactly the same idea with these rational functions. So notice that the 12 had to be factored in order for us to easily recognize how we could make a common denominator. We're going to do the same thing here by factoring this quadratic. So to factor this, we need numbers that add up to 3 and multiply to negative 10. So that's got to be a 5 and a 2, where the 5 is positive.
Couldn't you have a 5 this way? And couldn't it be the other way around? Like negative 2, positive 5, or... Oh, sorry.
So we've got x plus 5 times x minus 2 in the denominator. And as you can see, each of these rational expressions have x plus 5 in the denominator. All we need to do is multiply the first term, top and bottom, by x minus 2.
For the following students, please come to the main office. Destiny Park, Mackenzie Preston, Emily Robbins, Jared Rosa, Jalen Rose, Matt Gate, Catherine Seaborn, Jacob Smart, Parent Sweet, Owen Williams.
Okay, now that this is done, we have both rational expressions as fractions with the same denominator. So we can simply add the numerators. That is, we can add the terms on the top here to the ones on the top there, putting it all over that same common denominator. So again, just as here, we've got 2 twelfths plus 3 twelfths. We could add them together to give us 2 plus 3 over 12, which is 5 over 12. In this rational expression, this takes the place of the 2, this takes the place of the 3, and the denominator, that common denominator, takes the place of the 12. So we have x plus 3 times x minus 2 plus x plus 2. And this is entirely over x plus 5 times x minus 2. We'll use FOIL to expand out the quadratic term at the beginning. So this is x squared plus 3x minus 2x minus 6. Those 4 terms come out of expanding this, and then we still have our x plus 2 at the end. All of that's over x plus 5 times x minus 2. So we've got x squared, 3 minus 2 is 1, plus 1 is 2. And then minus 6 plus 2 is minus 4. All over x plus 5 times x minus 2. Now in order to factor this, we'd have to find two numbers whose product is negative 4 and who add up to positive 2. Now, I think no such numbers exist. If we look at all integral factors of -4, we've got -4 and 1, +4, -1, 2 and -2. And no combination of adding these will give you a +2. So our numerator is not factorable. We could expand out the bottom to put everything in standard form, giving us. And if we expand out the denominator, this gives us x squared plus 3x minus 10. And because they're more clear here, we should state our restrictions, and our restrictions are x is not equal to -5 and x is not equal to +2.